Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and good morning to all viewers and attendees. First of all, thank you MPC Chemical Productivity Nexus for organizing and inviting me to moderate this webinar. And also thank you all the attendees and participants, viewers for making time to attend this interesting and enlightening webinar. My name is Riwayat and I'm the moderator for this session today. In order to accommodate the majority of the audiences that we have, this webinar will be moderated in bilingual, English and also Bahasa Malaysia. Today's webinar session is one of the many series organized by MPC. And the title or the subject of the talk today is Total Productive Maintenance, or TPM, in chemical plant. I consider this topic to be interesting, and all of us will be enlightened by the speaker who's very knowledgeable. I would reckon that it would be beneficial for organizations to adopt this technique, the TPM technique, especially with those with many equipment and also machineries, not only for chemical industry, but for various types of other industries as well. For your information, there are two parts of this webinar actually. This morning, the speaker will share on the overview and also the practice of TPM in chemical plant. And this afternoon, at 3 p.m., he will share about the TPM assessment in the chemical plant. The topic is a bit technical in nature, but the process and methodology follows very common sense and logical steps. So it's not very hard to follow if we understand that step by step. And I hope all of you will enjoy this webinar. Yeah. Before we proceed, let's clear a few housekeeping items. Yeah. In order to ensure smooth flow of this webinar, the questions section in the control panel on your device are to be utilized. Yeah, the questions or the question can be posted in both languages, either in Malay or in English, as you prefer. Yeah. So depending on the situation, the time, if the time permits, all the questions will either be posed to the speaker during the presentation, or we will keep them until the end of the presentation. Depending on the suitability of the question, we will decide on that. If the time doesn't permit for all questions to be answered, the presenter may choose to respond them by email or WhatsApp. Yeah. For your information also, in your control panel, you can see there's a handout button where you can click to download the slides for you to refer now, or you can also keep them for your future reference. Yeah. So if you need them, please click to download the handout. Okay. Now, with us today, we are very fortunate to have a very distinguished individual whom is very knowledgeable and very intimate with the MPC Chemical Productivity Nexus, and he will share his knowledge and insights on TPM in chemical plant. This is the part one, yeah, and he will share the overview and also the practice and methodology of TPM. Yeah. So in the afternoon, like I mentioned just now, at 3 o'clock, there'll be a continuation of this topic. This is more on the assessment of TPM in chemical plant. Okay. Allow me to introduce our speaker for this webinar. His name is Dr. Adli Ferdin Ramli. Dr. Adli is a fellow of the Industrial Engineering Operation Management Society International, or in short, IEOM, which is based in Michigan, United States. He has been an auditor, assessor, trainer, consultant for operational excellence since 2001. His experience is in the automotive field, where he focuses on operational efficiency through by using Lean, using VSM and Lean techniques. He has audited and assessed many organizations, including giant chemical plant such as Lotte Titan, Hitachi Chemical, and Industrial Resin Malaysia. Dr. Adli is also the founder and the director of EFR certification. EFR certification is an international certification body. He conducts a variety of high-impact training and workshops in the areas of workplace improvement, waste reduction, problem-solving techniques, and stuff like that. Because of his extensive exposure in various management systems, he has actively involved in the areas of auditing, evaluating, assessing, consulting, and training in the area of business excellence, operational excellence, lean management system, ISO 9001, IATF 16949, ISO 14000, ISO 45001, business continuity to all level of organization, including SMEs and also the multinational companies. Without further ado, please, I would like to invite Dr. Adli to share with us a topic of TPM in chemical plant. This is part one. Like I mentioned, part two will be done later. With that, Dr. Adli, please welcome and share your thought and insight with us. Proceed, please.
Okay, thank you, Riwayat. Bismillahirrahmanirrahim. I think it's some over-exaggerate about my profile. It's okay. First of all, I'd like to welcome all the attendees that willing to spend the time with me about 1 hour to discuss about this TPM or total productive maintenance. Okay. Without further delay, I think straight away I go to the three main objective, okay, of today, what we call webinar, in which on the first part, I'd like to share about the what we call the concepts and application of TPM. Even though this is quite some time already, almost 50 years since 1971, with Jadina Kadima, introducing this total productive maintenance until now, it's already 50 years. So actually it's older than me. Lagi tua daripada saya. Okay, so maybe when they are getting older, means we have more case study to share on this TPM concept and application. Okay, so that's first part. On the second part, the most common measurement in TPM to talk about the effectiveness of the plant or the equipment is OEE. It's called overall equipment effectiveness, and this OEE is quite comprehensive. Okay, but yet it's quite simple to measure, so that we will understand what is the loss in the chemical plant in your productions. What is the problem? So I will share this on the second section. And final sections is just a summary about the 8 pillar of total productive maintenance according to Japan Institute of Plant Maintenance. Okay, so there's 8 pillar in which this 8 pillar also I will share in the afternoon sessions on the assessment. Okay, so 3 main topics that we cover. Number 1 is the concept. Number 2 is the OEE, and number 3 is about the 8 pillar. Right. So this total productive maintenance Okay, we have the keywords here. The first keyword is total. Okay, what is total? Later we're going to share about total involvement. So is when we use the word maintenance, the common problem is people will think about, oh, there's a maintenance department. Okay, there's a technician work. This is the maintenance engineer work. So actually, based on some of the story share with my actually share by one of the army, retired army. Okay, he served army in I think early 80s. Okay, and even my uncle, he also worked in army I think since 1960s. Okay, but 1960s maybe they didn't meet the those Gen Y ya, Gen Y kan, ayah riwayat 1990s Gen Y dia tak jumpa mungkin millennial. Okay, but one of my friends that work in army that start in 80s, they before retired they managed to meet some of the millennial and Gen Y. Okay, so he worked in the REMI or in army we call it JLJ, General Electric, General and Electric. Okay, he said that when he start his service, what he actually have to do, right, even though he's a mechanic, okay, he only do the big tasks, for example, like overhaul the engines, okay, do the major services, but he say he never do any change of lubricant. Then I asked, who changed the lubricant? Who changed the lubricant? He say it is a driver of the trucks or the driver of vehicle have to change that. Because he said lubricating and so on actually is supposed to be a driver work, because he want the ownership about the trucks, and that's during the British time and so on, and most of the ownership of the looking after the truck is owned by the driver, because the driver the one who drive their trucks. Okay? Because if you didn't give the ownership, they only know how to hantam only, drive like 130 kilometer at highway, and they didn't take care about their machinery, because they know when it's breakdown, there is the maintenance department going. So this concept, then when I look back, yeah, there is some true about it, in which if we apply in a chemical plant, the operator of the chemical plant should have, or shall, and the stronger word is shall have a responsibility on how to take care their equipment, when they have to do all the cleaning, when they have to do the condition-based monitoring, when there's a vibration, you have to report out, so that the equipment can be constantly, in this slide, I show that constantly in the best possible condition and able to perform full capacity. Okay, so that's why in this TPM, the word total means the total involvement. And then just as a total quality control, company-wide implementation of TPM is a company-wide implementation of plant maintenance, okay, which is consists of preventive, condition-based maintenance, autonomous maintenance, health and safety of the plant, and so on. Okay, we're going to talk that in the 8th pillar. And the TPM is therefore a philosophy of manufacturing that focus on the effective relationship of worker to the equipment and total elimination of waste. So means sometime in the equipment, we must have the feeling with the equipment. When we love the equipment, they will work best for you. Okay, but you hate, you start kicking your machine and so on, then means that you have bad relationship. Actually, the equipment, the machinery also have the feeling. So if you didn't take care of them, they're not going to take care of you. Then your equipment will not efficient. Okay. So a bit history is basically introduced in Japan in 1971. is actually introduced by this Seiji Nakajima. Okay, but the Japanese Institute of Plant Maintenance actually already there in 1969. And so that time, this JIPM, okay, they find that preventive maintenance is quite good. Okay, but like I mentioned, if we didn't give the ownership to the operator and so on, so sometimes the preventive maintenance cannot achieve the target. Okay, so actually it's growth from start, people reacting to the breakdown. Okay, for example, we have a car, we just drive aggressively without maintaining it. Okay, so what happened? Maybe hopefully it's not happened to us. Riwayat kita harap tak berlaku kat kita lah, rosak tepi jalan. So it's the
Yeah, hopefully not. Yeah.
because breakdown maintenance is something like we consider as emergency already. Okay, so we need some procedure for breakdown maintenance. But if we can prevent that breakdown, that's even better. Then we move to the preventive maintenance. So we do all the necessary changing of parts. That's preventive maintenance. Okay. After that, there is a stage where the preventive maintenance move to the productive maintenance. So this productive maintenance means the maintenance is linked with the performance of the organization, linked with the performance of the production, linked with the performance of the quality. So it's involvement of productive maintenance. And final stage is a total productive maintenance. Right. So the main objective about this is maintenance and for the total productive maintenance here, maintenance and management of equipment are set up as a system. All level of employer are involved from top line to the operator. Okay, so we can see what is the difference between breakdown maintenance, preventive maintenance, productive maintenance, and total productive. Most of the company that I audit, I riwayat, basically most of the company they have these two. They call it breakdown maintenance, and then one is the preventive maintenance. Normally they call it PM. This is basically we call some company call it CM, corrective maintenance. Okay, so when there's a machine down, okay, then they do some the corrective to make sure the machine is up. Okay, so this is quite common, but productive maintenance, even though it's 50 years old, especially in SME, small medium enterprise, actually it's much more easier to implement the TPM. But however, I find that the lack of the efforts to ensure the total productive maintenance, and most more okay because maybe at the plant, for example, the small chemical plant, I didn't talk about the big plant. Okay, the small chemical plant because most of technical thing, the boss do repair machine, the boss also do run the machine, also the boss do. Okay, so that's why I say it's much more easier. But he also have to consider about how to ensure his operator and also can do the maintenance as well. Okay, so the total meaning is total effectiveness, total maintenance system, including preventive maintenance, maintainability. Okay, in other words, total here it means that before we buy the piece of equipment, we already consider the maintenance. Okay, there's one pillar later I will talk is about early equipment management. Because sometimes the problem is when the salesman come, they say their equipment can do this, can do that, and so on. Okay, but after you install a few months, it have breakdown. Actually, nobody know how to repair it. Nobody know how to troubleshoot. Okay, so that's why in the total productive maintenance is also include the early equipment management. Okay, I think that's why in Malaysia, I think this is quite true, especially when people want to buy a car. Betul ayah riwayat.
Yep.
Basically before people buy a car, I say ni kereta senang maintain ke? Spare part cheap or not? Okay, so that's mentality also need to be what we call integrate into buying the equipment, machineries, and so on. Okay, and then of course the total participations from the employee. Right. So let's talk about simple case study here. We consider a big organization, okay, but the name of the company we keep anonymous. Okay, the name of the people we keep anonymous as well. All right. This is one of the plan actually already start investing a lot in the fully automation, especially nowadays. There is a lot of grant, okay, to do the IR 4.0. Right? So there is a lot of automation can be done. Okay, there's Internet of Things. Okay, so the company start investing, okay, and then receiving some grant from the government. Okay, and then the quality of the product is maintained or the mixing of the product is all using the PLC. Okay, quality of chemical depend on the mixer capability in maintaining process stability. Okay, with their plant, they are fully automatic with PLC system. Okay, which is the ratio is all automatic mix. The chemical A, chemical B, and then they put in the water. The additive is all automatically. The mixing time, setting up the pressure, setting up the temperature is all automatic. And then, of course, the final product cannot be measured if it in the reactor, in the blending machine. You cannot measure the products. Okay, so they only can measure the process parameter. Okay, since the process parameter measure automatically, what we can do is to get automatic equipment run properly. Okay, and what I find also is some of the displays it doesn't work. I asked like, what is the current pressure right now? They say it's correct. As long there is a green light, correct. But what is the pressure now? I say it's supposed to be inside that meter, but I cannot display. Okay, so that's why I say, okay, your organization, your plant need TPM. And based on the observe, okay, so this is not true story lah. Next slide. Okay, so this is maybe some we chit chat in the canteen. Okay, we talk with the operator. I ask about okay, what is the your work right now? Macam mana kerja, bagus ke? So some bit summary lah here. So this name anonymous, but I put some name like Ali Hantam saja. Okay, Ali Hantam saja. Okay, Ali he operate this bit of kit. When he break down, he call a maintenance repair. So if maintenance come late, okay, that's good for me. So I can relax in the canteen. So when it's amended, when it's repaired, then I operate back. Okay, that is my job, and it's what I get paid for. Okay, this is some of the mentality of the operator. Okay, because he say he's been paid to operate the machine, is not to repair the machine, not to troubleshoot. Okay, so then we have some chit chat next with the supervisor. Okay, the supervisor always, if we look from the statement here, look like it's a very negative person. Okay, he say that I work operator like scared. Okay, got to keep them busy, keep them occupied. This plant keep breaking down. The maintenance doesn't do the work. They are prima donna, just sit down in their workshop office, play Facebook, play game. Okay, when the kit break down, I have to do some reorganization. Some operator rerun to the canteen, I find them back, and then maintenance usually take time to repair, so it's really headache. Okay, sometimes spare part is not there, but the management keep us to get the output. So this is Abu Tiao. Kerja dia tiao orang tiao operator, team operator, and so on. Okay, so this is supervisor point of view. And then let's move to the next one. Okay, this is the maintenance guy. Okay, look like I riwayat juga tapi nama dia Mustafa Peneng. Sorry, cuma IR ada rambut ni tak ada rambut ni. Tadi lagi Peneng kot. Alright, so most of issue when we talk with the maintenance, they say about the maintenance budget. There is no budget at all sometimes in the organization, and sometimes there is a budget, but always when they want to request it, they cannot get it. And then he said that the plant, the machine is old, and some of the machine is look like World War II type of machine. Okay, some of it is really new. Okay, so but those the new one. Okay, the electronic is too complicated. Like Mustafa Penang say, we need to have a degree or master or PhD to understand it. Who designed this this machine at the first place? Okay, it is like impossible to maintain. It's look like if you want to repair it, we have to change the whole bunch. No wonder we use so many subcontractor, production keep on at me, but unless we get more men, we're going to sink, and then the plant cannot produce them. Right, so this is maintenance engineer Mustafa Penang. Okay, so dah hilang dah rambut dia. Okay, and then we have.
Okay, before that, Dr. Adli, there is one question. I think we'll take that question at the end because right now it's already 10:30 and we are supposed to finish at 11. We have only half an hour to go. So we'll ask a question at the end. So I just want to let the participant know that. Okay, we have only half an hour. Yeah, okay, thanks.
All right. So the next one. Okay, so this is another issue in the production. Okay, in the chemical plant, which is there is a group of the people that like to invest in new machinery, like to have the new design and technology. Okay, you get a chance to try out idea, play around. Okay, and then he mentioned that about IR 4.0, we're going to replace people. Okay, some of the new plant is state of art. It can do just about anything. Okay, so nowadays with the automatic vehicle machine and so on. Okay, so there is a lot of that. Okay, but the problem is other people like operators, supervisors. Okay, they cannot catch up with that. Okay, and then from here we can see the typical production plant from this case study. Operators look busy, they come to work every day, but plant didn't produce the output. Okay, operator doesn't know what's wrong and don't really care because they say that they got paid for to come to work and not to look after or repair the machine. Maintenance spend a lot of time reacting to breakdown. Majority of breakdown are simple and repeating. Operator are bystander watching their plant deteriorate. Management cut the budget. Okay, and effectiveness, of course, a lot of money, but true cost is hidden. Okay, so did your plant have this issue or not? So we're going to go to the second chapter, in which we have to measure first. Where are we? Our plant is ideal, like the statement from this slide. Your plant is producing the product as what it's supposed to produce, right? So we can use one of the quite famous measurement. We call it OEE. Okay, OEE is a measurement that basically consider, I can consider it total. Why? Because it's consider in the measurement is considered about availability. Availability is uptime. For example, if you work 24 hours, okay, how long your machine or your plant is running? So 24 hours is around 22 hours, means the availability is 22 hours. Okay, but if you have a problem of breakdown and so on, so the availability will be reduced. This is first performance that we're going to measure. Okay, whether your machine is producing the product, or is it stand still, or is it breakdown, waiting for spare part, or waiting to be set up. Okay, so this is the first measurement. Second measurement is on the performance. Sometimes when the machine already have wear and tear, okay, there is a tendency that we're going to slow it down. Suppose it's supposed to produce 1 ton of the product in 1 day, but you have to slow it down, so it only produce 800 kilogram. Right, so this is the second measurement. Okay, but the problem is whether this 800 kilogram can be used or can you sell, or you have to rework it. So you have to rework it. Okay, so we're going to measure the yield. So overall in here, okay, it means that overall we consider the 3 factors. One is A, availability. Number 2 is the performance, and number 3 is the quality. Actually, we can measure all these 3 and then we can times it, so it become overall equipment effectiveness. Okay, let's look on the example on the next slide. Okay, so on the next slide, basically we talk about 8 big losses, but let me show okay the example first. Okay, so we move to this example first. Okay, so on this part, okay, plan operating time. We take example, this is 1 shift. Okay, so in 1 shift, okay, they're supposed to run 8 hours. Okay, they plan to run 8 hours. So if they run 8 hours, they are supposed to produce 1,000 liter, or 1 ton sometime, 1,000 kilo. Okay, availability, they have 2-hour downtime. So it means it's only run 6 hours. But it produce instead of 1,000, so it only produce 750. Okay, so means you lost 250 there. And then performance. Okay, because of the machine cannot be run at optimum, so it's only run at 80% speed and not 100% speed. So they run 80% speed, in which if they run 80% speed, they're supposed to get 750 liter. But actual production, they only get 600 liter. So they already lost 400 liter. And then after they do some sieving of the product and so on, the one that can be used, okay, is only 500 liter, which is 90 liter have to be scrapped, maybe because in the front of the process they have to throw out some of it, so it left 510 liter. Okay, it's supposed to produce 1,000, but you lost almost 490 liters. Okay, so we can do measurement of this. Okay, where all this loss come from? Okay, it lost from the availability losses. Okay, and then we lost in terms of performance, and we lost in terms of quality. So that's why in this slide, okay, the previous slide, basically we show about the example of the losses. So if you look on the example of losses, okay, inside here, okay, there is due to shutdown is one of it. Okay, production adjustment. This one is normally setup losses, because the longer the time you set up, because you have to do the charging of the chemical and so on, that is also considered loss, because it's supposed to run 8 hours, but you set up 2 hours, so actually you already lost 2 hours from there. You lost 2 hours production time. So 2 hours from our previous case study is almost 250 liters of product. Okay, and then equipment failure, process failure. This is the 4 losses in availability. Okay, performance losses is idling and minor losses. Okay, sometimes we already operate the machine, okay, but we have to slow it down because there's some issue that, for example, in the dilution, okay, we have to put some chemical or some water to dilute it, but the problem is that nozzle stuck. So instead of we can pour fast, now we have to pour it a little bit slow. You have to charge a bit slow. So idling and minor losses is considered as the performance losses. Okay, and then quality defect losses. Okay, we always consider here the first time quality. If you have to rework, okay, that is considered quality losses. First time quality means the measurement. Okay, first time we produce 1,000 liter. Okay, but after that, only 500 liter can use. Another 500 liter, okay, you have to send for rework. Okay, so that is actually quality losses, right? So on this availability performance losses, if you measure it, basically what you can identify, okay, here is the calculation. Okay, so the calculation here actually is measure in terms of availability is 75%. Actually, is when you want to calculate is 0.75. 0.75. Okay, and then you time, okay, because of performance losses is 0.8. Okay, and then quality is time 0.85. 0.85. Okay, if you time all these three, so it becomes 0.51. Then you time 100, then you get the OEE. Okay, if your OEE is 51%, it means you lost 49. If your OEE is 70%, you lost 30%. Okay, if your OEE is 95%, then you only lost 5% in terms of downtime, in terms of quality, and also in terms of performance. Right. So some people ask me, what is the best OEE? Okay. Actually, there is no right and wrong answer. Okay, it's because it depends on what is your baseline measurement first. Okay, if your baseline measurement include the setup time, the downtime, and so on is already more than 85. Okay, so you should set a little bit higher from there, and maybe you should set 92% or 95% OED. Okay, but to be honest, when I visit the chemical plant, most of the plant, even to get 85% is not that easy. Okay, actually, most of the losses that they have, okay, is on the downtime. Okay, if you measure it in quarter, but if you measure it daily, maybe you can see good result. But suddenly the plant or the chemical plant have a problem, there's a downtime, it stopped for 3 days. Then we can see in that month, okay, the performance will be down. Okay. So basically that is what we call what we call the performance of the world-class OE. So it should be 85%. If you got 50 or 40, don't worry, okay, because that is quite common. 40, 50, 60 is quite common in most of chemical plant. Okay, and then try to improve to 85. Okay. So we move to the next one. Okay, and the final parts of this OEE is I like to share about 8 pillar of TPM. Okay, so but before that, since I've been talking almost 40 minutes, so I Riwayat, anything like to share because the final part is quite short.
Okay, so far so good. Just maybe for the benefit of the audience, you mentioned about the OEE, and this is all on the overall equipment effectiveness. So maybe could you share with us whether if the industry without any equipment or machinery, can they still use TPM as well?
Without equipment and machinery. Okay, so normally we measure it by the equipment, plant, or the machinery. Okay, and the best we prefer it is one line. For example, if the process is consisting of chemical reaction, okay, after that we have the dilution and then we have blending. Okay, if we can measure it in one line, in one line is even better. Okay, but some company they find it difficult because after they do the reaction, they didn't do the dilution immediately. Okay, they say they're going to keep it first, okay, and then they will do dilution on next day and so on. Okay, but if it continuous process, we prefer it again until the end because we need to measure the output here. In the performance, basically we measure the output. Okay, in the quality, we're going to measure the quality output. Okay, so if we cannot measure the output at the end of the process, okay, I think the OEE cannot be measured. Right, so it needs to be equipment. It needs to be equipment because it talk about downtime and deliverability. Thank you. I rewind.
Yeah,
That's good
okay.
question.
Yeah. Your
Okay.
video is off, Dr. Lee.
Video means my sharing.
No, your own face. Did
Oh,
I
okay.
miss? Yeah.
Okay. I think it's
Oh,
automatically
okay.
off. Maybe internet problem. They use less streaming maybe. Okay, thank you.
All
Thank you
right.
for remind. That's good. Okay, so the 8 pillar of TPM. This is actually take from the GIPM. Some literature may have different points. Different points, but I find out that this 8 is should be sufficient. This afternoon, I will share. Okay, I have about 14 points. Okay, I have about 14 points. Okay, in the assessment, for example, I include budget and budgeting the financial in the assessment, okay, of your plant maintenance. Okay, so some people say budget is under efficient administration. Right, so it's okay. And then I also include the repair facilities, the workshop. Right, the repair facilities, the workshop. In this 8 pillar, actually, I didn't mention about workshop. The repair facilities. Okay, but again, I either put under the efficient administration. Okay, to consider as the workshop efficiency, because sometimes the, the chemical plant workshop, okay, their 5S is really bad. Okay, they cannot find their spare parts. They cannot find their parts and so on. Okay, so we can consider that under the pillar number 7. Okay, so what is the 8 pillar of it? Okay, the first pillar in TPM is, of course, we need the continual improvement in your plant. So we need the Kaizen activity in the maintenance. So without Kaizen activity, even though MPC have like Team Excellent, we can use a Team Excellent, we can use ICC to do this focus improvement. And starting, normally focus improvement start from the what we call the OEE itself, right? Because OEE will tell you, okay, you have problem in charging of a chemical, you have problem in the breakdown, you have problem in autonomous, that means the involvement of operator. Okay, so we can do the Kaizen. Okay, the second pillar is actually autonomous maintenance, which is the operator itself, okay, have to do a basic maintenance, right, of the equipment. This is autonomous, for example, like lubricating, the cleaning, changing of the filter, right? So a simple maintenance, okay, should be done by operator because they are nearer with the equipment. Okay, and then plant maintenance or preventive maintenance. This is quite common activity, which is including the CBM, condition-based monitoring. And then we have training. One of the middle pillar here is quite important is EEM. EEM actually is the early equipment management or maintenance. Some people use maintenance, some people use management. Okay, in which before we embark into IR 4.0 example, before you embark in automation, okay, consider about the maintainability. Is the spare part easily available? If the internet is down, is it still can operate? Can we use the hardwire instead? Right? So this is the important parts, because if you already invest, okay, and then you have a problem to get it maintained, to get the parts, of course, later your OEE will be going down. Right, and then quality maintenance, this is more on documentation of the maintenance activity, maybe the checklist, the SOP, the procedures, efficient administration, including the budgeting, okay, including managing your spare part, managing your workshops, okay, and of course, the most important pillar, especially in the chemical plant, is about safety and environment. We also don't want your plant to be shut down by DOS because of incident. We also don't want DOE, Department of Environment, to stop your plant because there is spillage, or maybe you have some leakage that can cause the pollution to the environment. Right. So in the slide, okay, basically I have a simple explanation about this 8 pillar, right, that which is is your TPM, to build your TPM, or to build your house of the plant maintenance, okay, because in each of this pillar will ensure that your roof, which is your roof means your quality of product, your OEE is maintained well. Okay, so focus improvement, like I mentioned, is a Kaizen. Okay, it's a Kaizen activity in your plant maintenance. If you don't have that, okay, later in the afternoon we talk about assessment. Maybe you have less score in this. If you have activities, okay, but not documented, also you're going to have less score, because some companies, they say they do a lot of especially this maintenance engineer and the technician, okay, on in terms of their documentation, they are quite weak. In chemical plant, I found that they are quite not strong in preparing the reports and so on. Okay, so some of them even tell me, okay, I work with the spanner, not with the pen. So that's why it's a bit hard to tell them, okay, some of your improvement that you do, you should document it. At least you document it before and after. Okay, Kobatsu Kaizen. Again, there's the first pillar. You must have this activity. Okay, second, you must have the autonomous maintenance. Okay, which is we need to do the cleaning, we need to do the tightening, okay, on certain bolt and nuts, because the machine is running, there's a potential, okay, it loose, you need to do some lubricating, you need to do some data collection, okay, that is need to be done by those who are in the front of the on the machine. Okay, and then the next one is a planned maintenance or preventive maintenance. Okay, so this planned maintenance is to increase the mean time between failure. Okay, in which we need to specify the activity by ranking up the machine or the plant. Okay, so which one is important is machine plant A. Okay, so you need more preventive maintenance. And there's a machine type B, maybe it's left maintenance. Okay, and then C, okay, even sometimes some people use until fail. Okay, for example, our light bulb, we seldom do the preventive maintenance or change it before its failure, because we know that to change it very fast. Okay, even it's down, one light bulb down, it may not affect the production or the output. Okay, so that may be C ranking or D ranking type of the equipment or machinery. Okay, and then another important one under this plant maintenance is about CBM or condition-based monitoring. Okay, so this condition-based actually we going to measure, for example, the vibration. Okay, because we know once the motor, their bearing has a problem, okay, they will vibrate badly, or maybe before this is vibrate, but not bad, okay, but when the bearing start wear, okay, actually it give you a sign. And so we do the condition base before it fail, then we can plan when to change it, especially when you do the shutdown. Okay, another type of condition base is temperature. It's quite easily. Nowadays, temperature handheld temperature is cheaper. Now, everywhere we go, we have the temperature scanner, so we can just use that as well. Because okay, but that one is for 37 degree, like 36. Okay, but you can use the handheld one, and maybe a few hundred also. If the machine should be at the optimum temperature is 75, we can check. Suddenly it's too hot, maybe it's 90. That consider potential problem with your equipment or machine. Right. So this is plant maintenance. Condition-based monitoring. Okay, this is some of the oil sampler also. It can be considered as the condition-based monitoring. Emitter or suddenly volt or the current is getting higher, there's potential more frictions, and then infrared imager and so on. Infrared imager also is quite famous now. In some of shopping complex, we can see our temperature as well by using this infrared imager. Okay, so this is something that can improve your OEE. And then training and education, we have to train our operator, we have to train our technicians, maintenance engineer on new things, especially nowadays when we want to embark with IR 4.0. Okay, we need the organization readiness. Your people is ready. Your people know how to use a smartphone, for example. But nowadays it's okay because smartphone will be used for My Sejahtera. So the awareness on using the smartphone is until like 60, 70 years old. Pakcik-makcik also now can use the smartphone. Okay, so you need the develop training plan, training activity to get this TPM working. Like I mentioned, okay, this is one of the important parts early equipment management. Okay, when I visit some of the plant, okay, I ask, okay, who decide to buy this motor? Who decide to buy this pump? Who decide to use that reactor? Blending. Okay, it said the boss. Okay, who is the boss? Okay, actually it's our CEO, our managing director. Okay, he involved any technical guy or not? Okay, he invoiced. He just discussed with the contractor, with the supplier. Okay, then when is the maintenance involved? Okay, once the plant has been installed, then they will give to us. Okay, that is too late already, right? So the decision to install, to buy the new equipment, to buy a new pump, new machine, it needs the involvement of the production and also from the maintenance. Then I discuss, a few questions, there's few checklists that need to fill in. Okay, if the score is high, then we proceed to buy the equipment. If no, then we should find the alternative, because we better to be difficult early rather than during the mass production. Okay, pillar number 6 is the quality maintenance. It's more on the documentations, on the reporting of the maintenance activities. And then the efficient administration is more on the workshop, on the spare part control, okay, on the purchasing side, how to contact the contractors to repair, what type of the problem that we need to outsource, okay, what is the process that we need to outsource to the contractor to do the preventive maintenance, is all under efficient administration, including the budget, including the budgeting. Okay, so that's efficient, and then on the final part is of course safety and environment. Achievement of zero accident in a healthy and clean work environment. Okay, so my final parting line. Okay, the benefits of TPM. Okay, is target to have zero failure, zero defects, zero accident in your plant. So that's why we need the TPM. So I pass back to Riwayat, okay, so for some discussion and question I need to ask about TPM.
Okay, thank you, Dr. Adli, for very insightful information and sharing with us on the TPM. And the continuation of that will be at 3 p.m. We come to Q&A time, Q&A session. Just a moment, there are a few. Okay, the first one, the organizational TPM roles, responsibilities and authorities shall be documented and communicated, such as through JD, training and routine communication medium. What is your opinion, Dr. Adli? I think you mentioned about this earlier. Maybe you can just briefly answer it. There are a few more questions actually.
Okay, so of course, when we embark to the TPM, we need the top management commitment. To start with this top management commitment, okay, is we have to agree on the job description. Okay, we can do some grading on the operator. For example, if the new operator and they have technical, they know how to do the troubleshooting and so on. Okay, that is the high level of the operator. Means maybe their salary scale is higher. We can put in the JD, okay, but sometimes we operator the turnover sometimes is high. Then when we get the new one, okay, we're not going to get those who know how to troubleshoot. Okay, so that's why in the JD we describe that. Okay, there's a stage 1 operator, there's stage 2 means it's technical operator. Okay, and stage 3 is the expert operator. Okay, so at least we have this described in the job description. Okay, and then important also on the maintenance parts. Okay, what is their job description? Okay, and then including normally on the maintenance parts, I always highlight this during my audit. Okay, is that the maintenance involvement in early equipment maintenance or early equipment management. That is important to put in there. Okay, and of course, other parts like supervisor and so on, they should have the job description. Okay, and then communicate to them if you already revise it into the new version. Right, Ayar?
Okay, thanks a lot. The next question is from Ting Tung Kiat. Hi, nice. Any set of participant for this seminar? I think this one will have to ask the secretariat. Dr. Adley and myself, we cannot answer for this, but we'll ask this to the secretariat. Sorry, we cannot give you this answer now. But normally, we don't give certificate for this kind of webinar. It's not a training; it's more of sharing. But anyhow, we'll ask the what do you call the secretary on this one? Yeah. All right. Okay. Next one. Yeah. Next one. Let me see. This is from Muhammad Zaki Tumijian. Okay. Assalamualaikum. Should we consider rework process as reprocessing losses or process failure if we identify the reject were due to new improvement on the process? You want me to repeat the question?
Thank you.
Okay.
I understand. Thanks. Okay, thank you, Mr. Zaki, for the question. Okay, so basically about the first time quality, like I mentioned in my presentation, a lot of chemical plant, they have the byproduct, unreacted chemical, which is we will pipe back and send back to the process or other process. Okay, we will consider that under the quality losses because we consider that as first time quality. So if we consider we expecting it producing 1 ton, okay, but 200 kilo is no good, that have to send to reprocessing. Okay, that is considered quality losses. Okay, but there is some chemical plant. Okay, they are using automatic system. Okay, they use automatic system. Means the unreacted chemical and so on, they move it automatically to reprocess back. Okay, due to the design of the process, we based on the R&D say, based on their experiment, they say they cannot get 100% complete reaction. Okay, so of course they have a byproduct. Of course they have some product need to be reworked or reprocessed. Okay, for that purpose, again, that is on the early part of the new product introduction. We're not going to consider it's under yield. Okay, we consider it because it's automatically we move to the next process because we consider reprocessing is process number 2. So when it's process number 2, okay, it's automatically if process number 2 also producing, let's say after they reprocess, 200 kilo is been reprocessed. Okay, that 200 kilo reprocess and then it produce 150 kilo. So you lost 50 kilo only. So your yield, okay, is maybe 5% only from 1 ton, or the quality. But if it not part of the process, we consider that is the quality losses. Right.
Right.
Okay. So there's two scenario, right? Which is there's no correct or right answer. It's depend on the situation of the organization.
All right. More
Okay.
question. Muhammad something. I couldn't see the full name. There's also a second part of the question from the gentleman before this, but I'll go to this question first. The question asks about how about MTBF and also MTTR. I think you mentioned briefly on the MTBF just now, but maybe you can also speak about MTTR in the TPM.
Okay. So of course, OEE is the what we call the macro view. It's bigger. Where is your problem? Okay, if your problem is on the downtime, okay, now we can further analyze into another two metrics. One metrics is mean time between failure and TPM. Okay, because we want to know how frequent is your machine down, so that we can plan the preventive maintenance. So if it every week is going to be down, the MTBF show is every 5 days, every 7 days, then I have to have the preventive maintenance before that 5 days. That means that on the 4th day, I need the preventive maintenance so that that failure not going to happen on that 6 or 7 days. That is MTBF, in time between failure. We need that matrix. Okay, if your problem is on the downtime. Okay, another metrics that we can measure is MTTR, mean time to repair. Okay, this is one we want to see how effective is the maintenance team to respond to the breakdown. Okay, they take time to respond, maybe 3 hours. Right? So the machine is going to be down for 3 hours already, nobody entertained. So we want to know what is the average their response. Okay, so sometimes we said like 5 minutes. The technician must be there, okay, and then they have to repair it. But of course,
Right.
the further downtime, how long? Okay, it depend on the issue, spare part and so on. Okay, so these two metrics is additional metrics.
All right. The second question from Muhammad Zaki. Yeah. The second question, he said, should we calculate energy mass balance as one of the losses?
Energy mass balance. So currently, the current metrics in the practice is not available yet on that. Okay, but those the additional from OEE is TIP, TEEP, which is the include of utilization. Energy loss, so far I didn't find any literature yet. Okay, and based on my experience auditing or assess the organization, the energy loss is separate measurement to the OEE. Okay, but of course, if you want to measure it, can, but to integrate with OEE, I never encountered it.
Maybe it could also, if still need to be measured, need to consider that maybe that could be part of the performance. Yeah, we could include that part of performance. But we have to clearly define that lah. All right. I think thank you very much, Dr. Adli, for all the answers.
You're welcome.
And thank you the participants for the question. Yeah. We don't have any more question. And the time also now is 11:10, 10 after. And it has been, like I said, very insightful sharing from our speaker today. Thank you, Dr. Adli. And we have covered quite a bit of information, yeah, as far as TPM in chemical plant. Like I said, yeah, this is not only applicable to chemical industry, but also can be commonly utilized or adopted in other type of industries as well. This quite a generic, what do you call, methodology to all the other industries as well. And TPM is one of the tools in lean management, yeah, a tool to eliminate waste. Yeah. And okay, we have come to the end. And again, thank you, our speaker, Dr. Adli, for the
Welcome.
valuable knowledge, and also thank you, MPC, for the tireless effort to promote knowledge sharing, and also being a great organizer. Not to forget to thank you all the individuals who have made this webinar possible, including our attendees, viewers, participants, yeah, who have joined this productive session. Okay, at any rate, stay safe, stay at home. If you don't have to go out, stay healthy. However, let's continue to be productive by learning new things, or continue to sharpen our mind with the new knowledge. And the webinar is here for you to be, what do you call, to get this knowledge and all that, yeah? So thank you very much. I will end this with wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.